Excuse me. Refresh. Okay, that works. Let's go here and refresh. Okay, that looks good. Dashboard. Let's stream manager. Pop out. There we go. Leave it here. Okay. Think we're looking good. Right. Right. Okay. Ooh. Excuse me. Hang on. What am I looking for? Yeah, DNS. Yep. I went back and had a look at one of my videos, and I realized that I don't speak clearly, which I've always known about myself. And whenever I speak, it tends to be too soft or not clear. I think both of which I would like to get better at. So I thought, okay, this is perfect. I can stream and practice speaking more clearly. Oof. I can feel the clarity in my voice already. But yeah, so that's a side note. And yeah, other than that, I think I still didn't get anywhere too far with the Wi-Fi device yesterday. Yeah, still only about halfway through the data sheet. So I'm going to try and go through this. Hopefully it gives me the first next step. Let me bring the device. Okay. Yeah, what actually looks kind of nice, but I'm guessing it's like a kiddo board. I mean, I could do it on the breadboard. I like this better. There's a lot of cables here. Be nice if I could move some of them out of the way. Yeah, maybe some other time. Okay, I'll leave it on the side. Ugh. Okay, that'll do. I'm also not sure why it happens, but every time I plug it in, I get an error and the display doesn't turn on. I have to go back into, what's the name? Yeah, into boot select mode, and then put back the source code, even though it hasn't changed. Strange. Problem for another day. Okay. Guess I'll get started here. Okay. So just a little bit of a backstory. Well, story. That's not much of a story. I think ESP. Yeah. Remove that. It's got a lot of pins, which makes me slightly concerned. Yeah, so I've got like halfway through, or what I think is halfway through the embedded project that I'm working on. And the next step, so far I've written the display driver, and so moving on to, what's the word? I completely blanked out. Yeah, so right now I'm working on writing a driver for this Wi-Fi microcontroller. I don't know, whatever. Yeah, microcontroller. I don't even know if it's necessary or if it's going to be extremely complicated. But judging by the size of the datasheet, my guess is shouldn't be that bad. Okay, so there, you've caught up. Yeah, and the project, I'll explain that later again. Okay. Jeez, what was that? Okay, general purpose IO has 17 GPIO pins, which can be assigned to various functions by programming. Yep. Each GPIO pad, PAD, can be configured with internal pull up or pull down set to high impedance. When configured as an input, the data are stored in software registers. You know what I just realized? The display device, I can write something to it and then read it back and I can test it. Is that how they test devices? I don't know. And actually, the video device is so small in terms of memory and what goes on inside. I could probably write a what's the word? Simulation testing for it. It would be totally unnecessary, but it could be done. Okay, going back to here. When configured as an input, the data stored in software registers, the data are stored on software registers. The input can also be set to edge trigger or level trigger CPU interrupts. In short, the I/O pads are bidirectional, non-inverting, and tri-state, which includes input and output buffer with tri-state control inputs. These pins, when working as GPIOs, can be multiplexed with other functions such as I2C, I2S, my guess, UART, PWM, and IR, remote control, etc. I think UART is the debugging interface, or something to do with debugging, as far as I know. Okay, so let's have a look. Secure digital I/O has one slave SDIO. Oh, so you can connect. So I could connect. No, really? So that means I can connect my display directly to the Wi-Fi microcontroller. It does have a few extra pins. Huh. So yeah, I think I can. Because it does support I2C. That's fascinating. And it's got 1 megabyte of memory. I think it should be more than enough. That's cool. I think that's another side quest for this current side quest. I probably will do it. You know what I just realized? MicroZig doesn't have a driver for ESP. This one. Okay, let me write this down. Let's go DNS. I'm gonna create a to-do. Side quest to the side quest. What do you add? Where's the, okay, just, I think this is how you add preview. No. Space. No. You added a checkbox in Markdown. Oh yeah, here. Okay, space. Then connect the display directly onto the ESP8266. MicroZig does not have a driver for it. So write one. It's a big question mark, because that sounds a lot more complicated than writing a driver for a display driver. But sounds interesting, so I'll leave it there. Okay, I'll leave this to-do list open, because yesterday I had an idea and it got lost. It felt like a really good idea. Yeah, I think it was pretty good. It was fucking good. Okay. Where was I? Can even... What's the page number? 19. Yeah. Page 19. 32. Okay. Let's move on for now. Has one? Yep. And I only do need to... Oh, the question is, how would I connect it to my computer? Oh, or I use the Pico to program. Not complicated at all. How would that work? I don't know. That's a question for later. Okay, where was I? Yep. The has one slave IO, I think. For now, can skip past this one. Serial peripheral interface. Peripheral. It's not an easy word. So it has two SPIs. The slave master, general slave master, HSPI. Functions of one of these pins can be implemented via hardware. Yeah. Do I need to know about these? No. This one, yes. Oh, hang on. Okay, yeah, the SPI, not so much. I just realized that it's both for slave and master. So when I connect the Pico, okay, gotcha. But I think I'd rather use the I2C. Excuse me, because it's the one. Sleepy. Yeah, it's the same as the display, so it would be a lot more easier at this point. There's one I2C. Okay, the ESP has one I2C, which is realized via software programming used to connect with other microcontrollers and other peripheral equipment such as sensors. The pin definition of I2C is as below. There was the other. Damn cable. Okay. There's no numbers on this. I think I just disconnected. Pin number 9 and 14. There's no numbers on this thing. Hang on. Come on, display. Get your shit together. Very floppy. Right, straighten the cable out. I mean, it's not really better. Okay, I'll leave that there for now. I just realized it's also called ESP01. Yeah. Have I been looking at the wrong stuff? Cause this is what it actually looks like. Hmm. Does this have a... It does. Is it a different one? Uh-oh. Why is it sponsored? Who sponsors a datasheet? AI Thinker. Okay. I think it's made in China, so... Oh, that's tiny datasheet. It's not very useful. Datenblatt. Module Datenblatt. What's that mean? Oh, it's German for datasheet. Yeah, that looks a lot like what I've got. AI Cloud inside. Don't have AI Cloud. Excuse me. Schematics programming. Okay. Well, that's good to know. I've been reading. So I guess I can cancel my side quest. Because I was reading the wrong datasheet. But to be fair, that's what it looks like. What does SOC mean? That's what like Misoko asked me yesterday. What is SOC? Security? No. Three. In terms of, what's the word? Embedded stuff. What does SOC stand for? System on a chip. Okay. System on a chip. Okay. So my confusion is, maybe I just read both. You know, I think the side quest is still on. Hopefully I can undo. Oh, I've lost it. Side square quest. Connecting. Display directly onto the ESP8266. Like this in here, because I think the chip is still on that Wi-Fi device. We'll see. I think I'll leave the option open. Yeah. I'll come back to this one later. It's a lot smaller. Tiny. What is TXT? Guessing this is... No. Where's this one going? GPIO 0. It's got 8, 4 on each side, yeah. Okay, I'll come back to that one. Pins 9 and 14. MTMS. I don't see any of those. Okay. What is an I2S interface? Guessing it's square because this is square. Both I2C master and slave are supported. Clock frequency is 100 kilohertz. I don't know what to do with that information. Okay, has one I2S data input and one output, and supports the linked list DMA. Linked list DMA. Linked list DMA. Problem for later. I2S interfaces are mainly used in applications such as data collection, processing, and the transmission of audio data, as well as the input and output of serial data. For example, LED lights are supported. The pin definition. Does have don't understand this pin configuration yet. UART. Nah, I'm gonna go pulse width modulation. What is this? The ESP has 4 PWM output interfaces. They can be extended by users themselves. The pin definition of the PWM interfaces are defined as below. Damn, it's a lot of acronyms. P pulse width modulation. Cold. Okay. This can be implemented by a software. For example, Smart Light. Function of PWM is realized by interruption of the timer. The minimum resolution reaches as high as 44 nanosecond. And the frequency range is adjustable from 1000 microseconds to 10,000 microseconds, between 100 can't say 100 hertz and 1 kilohertz. When the PWM frequency is that much. The duty ratio, didn't know, never heard of that ratio before, will be 1 by that number, and a resolution of over 14 bits will be achieved at 1 kilohertz refresh rate. Yeah, I was curious what this was. IR IR remote control. So the ESP supports one infrared remote control interface. Oh, interesting. MTMS and GPIO 5. What is this MTMS? I don't see it here. So this can be implemented via software. NEC coding, modulation, and demodulation are supported by this interface. The frequency of modulated carrier signal is that much, while the duty ratio of the square wave is a third. The transmission range is about 1 meter. 1 meter. Well, you gotta be standing next to it. Might as well press a button. Transmission range is around 1 meter. Which is determined by two factors. One is the maximum current drive output. The other is internal current limiting resistance value in the infrared receiver. I don't see that receiver. What is it supposed to look like? See a lot of boxes. Moving on. The larger the resistance value, the lower the current. So is the power, and vice versa. Analog to digital converter. What's this for? An analog to digital converter. Is this mosquito? Dead mosquito. Is this, what was it called? The Wi-Fi signal, like, sorry, no, the radio signal to digital? Not sure. The T out, okay, is embedded with a 10-bit precision SAR ADC. Sounds precise. The T out is defined pin 6. What the fuck is pin 6? It's like, could be anyone. That's not very precise. It's below. Maybe I am the simple one. Pin name, pin number, function name. Pin name is T out, pin number is that, and the ADC interface is the function name. The following two measurements can be implemented using ADC. However, they cannot be implemented at the same time. Okay, I will take your word for it. Measure the power supply voltage. Pin 3, pin 4. T out must be floating. Float away. The 107th byte of the ESP init data default dot bin. Okay, 107th byte. Okay. Bytes. That's a lot of bytes just to initialize it. VD3 const must be set to that. So that's the voltage. Radio frequency initialization parameter. RF RF calibration process. Optimize the RF circuit conditions based on the testing results of that. Okay. Use system get that instead of system that. Okay. I have no idea what any of them mean. Okay. Anyway, it's still can be figured out. It's not that complicated. Okay, there's hardware design. The input voltage range is 0 to 1 when T out is connected to external circuit. Okay, I understand now. So these are the steps to measure the power supply voltage. It's alright. I don't need to know this, do I? And these are the steps to measure input voltage of T out. That could be useful. The input voltage range is between 0 and 1. T out is connected. Yeah, okay. The value of the 107th byte, that is a bit concerted. That's a lot of bytes. For example, when I initialize the display, I think there's maybe, okay, if I go 9 down, about 30 bytes. Yeah. So this is a lot more than 30. Okay. Unit and effective value range is the range of that const is 0.1 volt and 18 to 36 respectively, thus making the working power voltage range between that. Okay. It sounds like to me that this is like good to know information. I can move on. That's what it sounds like. Plus minus 2 volt. System read instead of get that. They keep mentioning this in this SDK. Let's have a look. ESP82. Hang on. Before I go there, electrical specification. I think I can go over power consumption. Unless otherwise specified, the power consumption measurements are taken with 3 volt supply, 25 degrees. Close enough. 3.3, I would say 27. All transmitters measurements are based on a 50% duty cycle. Whatever that means. Typical. Oh. Ooh. I've seen those before. Not these ones. Okay. So that's got something to do with Wi-Fi. I know that much. I don't know what these mean. Oh, TX, RX. Not sure what that means either. Okay, but I think it's power consumption. Fine. Okay. Oh, there's a dot. Yeah, there is a dot. Oh, that is convenient. It's tiny though, to like zoom in. What direction does it go? pin 1, and then 2, 3, 4, 5, 6. Oh, interesting. But I don't know. I guess for now, it's not very important. I can move. I'm at the appendix. That was a bit of a letdown. How am I supposed to write? Is that a ESP01? For detailed pin information, please see pin list. ESP, yeah. Let's go. Launcher 82. Don't know. That doesn't look very important. Yeah. Okay, I have another one. Digital die buffer. What is a buffer sheet? Register list, strapping list. What's that? Notes. Yeah. Some notes. Example. My back is still sore. Function number 1 to 5 correspond to function 0 to 4 in the SDK. There was a... I don't know what that was. Thought I was gonna have a sneeze. It was just false alarm. Okay. Have a look at this one. Yellow wire. Where did it go? Oh. I lost it for a second. Okay. FTDI M102 pin. Okay. Let's look a bit different from what I have. Ah, it's IO. I was thinking it was I square C. Nah, not even close. Okay. That makes sense now. Why is it 0 and 2? So this is this way. So it's no. Oh yeah. Ground 2 0 RX, then it's TX EN RST and ground. 3v3. Yeah. The VCC. Okay. So it's that way. I don't know if you can see it. It's like really tiny. And camera doesn't even focus. Well, it's there. Okay. Okay. So both the RST and power are connected to, what is it connected to? Yeah. VCC is here. What about ground? Okay. Ah, I see. There's a plus and minus here. Okay. Okay, gotcha. So both RST and the VCC is connected to power. The pins are like so close. I don't know how I would connect it on a breadboard. Ah, I would use those, the ones with the clips. Yes. Okay, and ground is here. It's 2 GPIOs. What about chip D? What is chip D? I have an EN. I don't know what chip D is. TX. Okay. Normal mode, program mode. So if you don't connect it, is normal mode. Okay, makes sense. Bit cold. .3 and not 5. Okay, yeah. Oh, it's got a 5 volt. I think the Pico only has a 3 volt output. No worries. No worries. Okay, programming. There are different ways to program. For example, Arduino. It's very familiar. Yeah. Just keep in mind, you are not limited to this option. I like that. There is an official SDK available to program it in real C. What does he mean? What do they mean? Real. C. They're looking at you. C++. I don't know. No comments. I haven't written C++ in... Let me check. It's about 2015, 10, and 3. Maybe in like 12 years. To be fair, I don't remember much about C++. C, I do. I did like C. Yeah, I think from my time in university or college, no, I think we call it college. Yeah. I think the only programming I remember is the one I didn't see. The rest I had no idea. I have no idea what else I wrote there. Excuse me. Okay, this is useful if you want to optimize your code. Yeah, they mentioned the SDK again. I'll have a look at it. Excuse me. He's quite burpy this morning. Do I see Lua? That's mental. Lua is everywhere. Supported by IDE. Another. By the way, another possibility is to flash it with a Lua interpreter so you can upload and run Lua scripts. Or maybe you're more familiar with Python, then you should check out the MicroPython firmware to interpret MicroPython script and many others. Okay, let's have a look at this SDK. Arduino IDE? Nah, don't like it. Yeah. What are the other options? Tools, blah, 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 blah. Oh, is that it? Oh, but maybe I can have a look at what do they actually set. Can download it here. What's this? Okay. Additional board manager. Okay. Well, plus I'm not using an Arduino, so I don't know if the IDE still works. Guess not. Okay, tools, boards. Yeah. Okay. And gonna program 8266, right? Okay. Genetic when you choose this board, there's some other options. When you open tools, after you choose generic ESP8266 module, there'll be several options you can set up. I'm going to leave it as it is. Just choose port on which your board is connected. Port, pin, not sure. And you are ready to create sketches and compile them for programming. Okay. Let's find this SDK. ESP8266 SDK. ESP IDF. Yeah, looks like from the same people. Important notice. Sounds important. The new branching model is applied. Master and release. Okay. Release, maintain, and hotfixes. Okay. Okay. The SDK's framework is quite outdated and different from, what's that? ESP IDF. Development framework. Ooh, there's some assembly. Oh, thought it would show me the assembly in here, but no. Okay. However, we will firstly provide a new version of the SDK. Okay. To be fair, do I care about the framework? Not really. Get toolchain. Question is, do I need the SDK? What does the SDK do? Is that a documentation? Yeah. Ooh. Newbies enter here. Yes, sir. Programming guides. Beautiful. Demo. Why do I have to download? Oh, maybe they have. Yeah, they do. Beautiful. Wi-Fi. Getting started. It's a good place. Station. Soft AP. Let's go with the soft one. Don't like this. Some Python here. Hey, actually, Python's really good. I think it was... I don't know, can't remember, 2 weeks ago. I tried to build a scraper with it. It is really easy. Yeah, it's quite an easy language. Excuse me. Okay. A Wi-Fi, what's okay? Project idf.py. Build the project and flash it to the board. Okay. Where's this output coming to from? Yeah, both. Station connected to that. Okay. Mm-hmm. ESP now. Sniffer. What does the sniffer do? Mm-hmm. Funny. Funny. Okay. I have no idea what this is doing. Ooh. Okay, hang on. Something. Buff. What is buff? Oh, okay, comes from here. Is it a callback? So you use it. Not sure. Anywho, frame, len, that, total num, count, blah blah blah, aggregation. ESP logi. Not sure if I need the SDK. Because to be fair, I don't know what the SDK is doing. Read the docs.yaml. Okay. Bit of a letdown. Components. Damn, they have an HTTP parser. Server, client. See, I don't need any of these. Protobuf. TCP. Yeah, maybe, not sure. Don't think so. Yeah, MQTT. Don't need any of these. Okay. Gonna have to SP. What is it called again? 01S. S. Hang on. This wasn't very useful. Maybe the Wikipedia page has something. ESP01. Okay. Mm, there's a few of them. Developed by home automation enthusiasts. Have a look at this. Is that a GitHub? Hey, what am I doing? What am I doing? Okay. SP01S. Okay, there's another data sheet. How to use ESP01S module. Browser. Okay. Okay. They do include non microsig.tech source egg drivers input display IO base. Datagram device. No. Find core. Tools? No. You have to ESP. Foundation dash libc. Include. Drivers. IO. 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 Stepper. Wireless chip. Let's have a look at this one. Semtech. Mm-hmm. 868. Damn. This is a data sheet. Looks complicated as fuck. Damn. All of them use the SDK. I don't know if it's necessary. How did people do it before the SDK? Breakout boards. Dun, 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 dun. Mongoose. I don't know. I'm stuck. Fucking stuck. SDK, pin list, hardware design. Technical reference. Isn't this STM32? This looks a lot different than the one I just read. So what did I just read? What is this? What is this? Datasheet. It is recommended to use the upgraded model. Oh, this is the only one I have right now. So I appreciate the recommendation, but must have resources. Okay, I'm gonna close this. This one, I don't know. This is like quite dense. ESP8266 technical reference. Oops. Okay. P82, sorry, ESP01S. What is it called? Oh, I know. I think this is a good question for the overloads. Do I need to use the SDK for ESP01S? All I need is to know. Do I need to know where the request? Oh no, is all I need to know is that if my router is making requests to certain DNS websites. I don't know about this one. Well, one reason I don't want to use the SDK because I'm lazy. I don't know how to make Zig work with C. Never done it before. Almost certainly. I don't know, makes me not want to use it more. The default firmware is limited. What do you mean? Oh my god. Fucking AI does slow. I thought I think too much. Well, to be fair, I didn't give it a lot of information. Just chill out, man. Don't need all that. It needs to connect to the router. I don't know. Network sniffing. To enter promiscuous mode. Okay. To capture all Wi-Fi traffic it can see I did see this sniffer. Let's go to the... No. RT... Hang on. ESP... 82. STK. Oh, they have a user manual. I did see the sniffer samples. It was Wi-Fi sniffer. See make list. Tools make file. Kconfig. So it's a lot of files. Okay. I have to figure it out. I don't know. Kinda confused. Let me have a look at where's the component. So how do you initialize? Someone forgot to sign the license agreement. I'm still leaning towards writing it myself. To be fair, I've got time. How long could this take, right? Because I just need the documentation. I2C user guide. Okay. And sniffer. Okay. We check chapter 9. Chapter 9. Does it have a index? Fuck is that? Appendix. Interesting. Oh fuck. Is this the 127 bytes? So now what this does. Hmm. I mean, it's not massive. Where's the UART SPI? Hmm. Suspicious. Okay. Hang on. Can I go to, yeah, chapter 9. There we go. Okay. Initialization. At least hardware initialization. How am I supposed to do that? Oh, through software? Makes sense. Okay, let me just read from the top. So it has interfaces for reading I2C master devices. Interfaces for, okay, yeah, because the Pico is a master device and allows control, and it's better off if it's a bit further, the mic. Maybe I can, is this better? Oopsie, it just totally came off. It's all floppy now. Sorry. Mic check. 1 2 1 2 1 2 1 2. Far away. They can still hear me. Okay. Whoa. Too much. Too much or not enough? Right. Okay. 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 Gonna start fucking with the mic now. Okay. That's good. Has interfaces for, too far. Don't want to shout. Not that I'm gonna be waking up anybody. Yeah, for a couple of days at least. Yeah, okay. And reading and writing over other slave devices. Okay. All pins can be configured with open drain mode, thus easily enabling GPIO interface for I2C data or clock functionalities. Besides that, the chip has pull up resistance inside, which can help save the pull up resistance outside. I have no idea what that means. 0. As an I2C master, hmm, hmm, don't know. I don't want it to be a master. I want it to be a slave to my Pico. Sounds quite bad. To my Raspberry Pi. That sounds even worse. Damn, the sun's up. Oh yeah, definitely quite bright. Okay. Pulse will be around that much. Initialization, no idea. But the thing is, I don't know which of these pins. Select pin functional. I'm gonna have to fucking look it up. Master stop. Master act. Act. Acknowledgement. Read data. Turn value. Read 1 byte of data. Demo. Oh, goes back to the SDK. Damn. What the fuck is with this color scheme? What is the address? U8 data len. Interesting. I can do that. Oof. This is quite rough. Don't know. What does one do in this situation? What is the sane thing to do? Yeah, let me get a new chat. If I wanted to write a driver for the ESP01S, how would I go about it? But what was his name? Mikosko? Yeah. If you're here, I'm open to any pointers. I'm a bit stuck. Well, I would say I'm totally stuck. Write a driver. I don't want to use it as a modem. that accepts. Okay, I should maybe specify what do I need it for. Okay. Text. Okay. Fuck. What do I need it for? Come on. Okay, my use case is pretty simple. I want the ESP device is connected to my Pico. What a Pico. And I would like to observe my Wi-Fi router passively to begin with. Not a perfect one. Oh well. Blah blah blah. Pico, yeah. Oh, what do you... VSys. Does it even have one of those? Interesting. Okay, I mean it's fine. Got another Pico. If I burn this one, try again with another one. Pin 36. Yeah, okay. But I can't change the connections because this one's like pre-soldered. Is that the right word? Yeah, I mean it's more convenient. Okay. You art. Why? I would like to use the I squares C. Okay. Fucking let's use UART, motherfucker. Fuck it. Yeah, it's turning into quite the drama queen. Okay. What is it connected to? Ground. Gotta have a look at the Raspberry Pico pin diagram. Pin diagram. There you go. One. Yeah. Where is... is UART? Okay. 17 and 6. Where is this connected to? Okay. It's connected to 16 and 17. Perfect. So transaction and RX. Correctly. TX bottom left. No, it's not. Was connected to 17. TX, okay. No. The fuck? What's a CSN? 16 connected to RX. Oh, so I am guessing, huge guess, gotta use the other one, the SPIO. Maybe, what if I turn it around? Nah, it won't work. This ground would be the other way. Mm-hmm. Yeah. Sharp. Okay, oops. Goes all the way through. I think I might have to use the SPIO. I'll think about it. I think I can use the UART if I want to. I just manually connect it. But yeah, I think I do. I can. Yeah. Okay. Da. Okay, where was I? Okay, yeah. Command firmware controlled by. Okay. The key command for passive scanning is AT plus clap. Here's a breakdown of how to do it using MicroPython. Connect ground, that, UART communication. Let's use UART 1. No, I'm going to use UART 0. convenient. RXD. Connect GPIO 4. UART 1 TX. This one. That's 8. The fuck? Even this one is 1. TX RX. Why is this one flipped? They make a mistake. Oh no, because the pins go up from here. Okay. I'm an idiot. I think it's connected the right way. So it's connected to 16 and 17. 0 all the way to 15, 16. Okay, no. I'm not an idiot. (16) and 17. I mean, (16) is RX. Yeah, no. And 17 is top 1 TX. So I'm guessing I was meant to use data clock. Chair is sinking. Okay. Six. Why would that reset anything? Optional reset. Just ignore the reset for now. Pico driver. Okay, you said the yeah, okay, no. Damn, 7 o'clock. Okay. I will come back to it. I'll probably go to the gym now. I might stream again later. I don't know. But I'll probably do something else. Can't be stuck. Damn. This was I got literally nothing done today. I'm still stuck. I don't know. I need a new direction. This one ain't working, chief. Okay. All right. I'll I'll be back tomorrow or later today. But if I do come back later, probably do something else. Think I've been working on a linter in Zig too. Might do that, or we'll see. I'm also got some bug fixes on my product, on my software. Maybe I might stream that. I don't know yet. All right. Hope you're watching. Hope you have a good one, and I will see you back here today or later today or tomorrow. See ya.